Okay, this is an interesting one. Which description does not guarantee that a trapezoid is isosceles? And there's something actually kind of funny going on with this that, I don't know, some of you might struggle with. So let's look at it. Congruent bases, I'm going to leave that aside for a second because I want to demonstrate that. Okay, congruent legs. Well, if we have two sides parallel, then the only way that, if they have congruent legs, then we know that their base angles are congruent. And then we're good. We know that it's isosceles. In fact, that kind of goes along. The congruent bases are the congruent base angles and the congruent legs, this meaning that, right? Just like in a triangle, that is an identification property for knowing it's isosceles. If you have the congruent legs, it's going to have congruent angles. It's going to match the description of it, okay? What else? Both pairs of base angles are congruent. Well, again, going backwards, that's just a fact about these things, is that both pairs will be congruent. And, you know, it has to do with the fact that the lines are parallel. And so if the lines are parallel, if that is parallel to that, then we're getting same side interior angles, right? And whatever that is, if these two base angles are congruent, then that's going to have to be that, like, if one pair of base angles is congruent, the other one has to be as well, just the way that it will work. If this number is the same as this, then the other number that adds to 180 will be the same, okay? So I'm going to scribble that out. And congruent diagonals. Well, I did this little kind of thought experiment with you, where if we take a rectangle, which has congruent diagonals, and then I took the two base angles, or the base kind of vertices here, and I dragged them out at a consistent rate so that the diagonals stayed congruent like they were when it was a rectangle, we would end up forming the same angles here, right? If you started to drag that increasingly out further until it was there, doing the same at the exact same rate, okay? And you got that, and you would get base angles being the same, and also, of course, the diagonals would stretch accordingly from the vertex here and here at the exact same rate, continuing to stay equal. Okay, so it's not that one. And what's really going on here with this last one, and let me get all the rest of this out of here. Let's see if I can do this somehow. So remember, the bases are the top and the bottom sides that are parallel to each other, yeah? So if we had them be congruent, they're either directly kind of their endpoints here and here are basically perfectly aligned up and down. Like if we drew a line through them, you would get a 90-degree angle, right? They're perfectly aligned like that, in which case that's a rectangle, and that means the other sides would be parallel too, and it's not a trapezoid then because you have to have only one pair of sides parallel, right? Or we dragged one, let me just do a little bit of eraser trick here. They're the same length, but they're not lined up, in which case still, if you connect the other, like if you connect the vertices there and there, those two sides are also just going to be parallel as well. No matter what, if they have congruent bases, then those congruent bases, sorry about that, those congruent bases, because they're parallel and they're congruent, that's a way that you prove that something is a parallelogram, if you recall that. Do you remember if we said these two are both parallel and congruent, then we know that it's a parallelogram. You can't be a parallelogram and a trapezoid at the same time. Trapezoids have exactly one pair of parallel sides and not two. So congruent bases indicates that we already know if they're the bases that they're parallel, so it indicates that they're both parallel and they're congruent, making it a parallelogram, not a trapezoid. So that's impossible for that to be a thing that tells us it's an isosceles trapezoid. So no such thing as a trapezoid with congruent bases. Yeah, fair enough. Okay, so we're done.